gonna have like a circle like this, right? So now we're gonna have the intercepts minus r, r, minus r, r, like that. So that's our circle here. And we want to rotate this about the vertical axis then. We're gonna rotate that about a vertical axis. And when we do that, remember this is our circle, and we're rotating it about that vertical axis. So doing that, we're gonna end up with something like this. We're gonna end up with a sphere of radius r. When we do that, we're gonna end up with a sphere of radius r. Sorry for my sketch, but then yeah, you get the whole idea of what's happening. So we know that the equation of this kind of circle will be provided by x squared plus y squared equals r squared. That will be our circle. And now, since we're rotating about the vertical axis, that means we need to solve for x, right? We need to solve for x. X will be our radius of that rotation there. So when we solve for x, we get x squared equals r squared minus y squared. When we do that, and then we solve for x, and then we get x equals plus minus the square root of r squared minus y squared. It's negative below the x-axis and it's positive above the x-axis. So now remember the disk method. It's gonna be pi, the integral from a to b of our radius, and this time is in terms of y square dy. So when we do that, we have pi, and remember we're going from negative r to r, just r. This is r, positive r, minus r to positive r of plus minus the square root of r square minus y square dy. And notice that this square is going to remove this plus minus sign, because if it's negative, square that, the negative goes away. If it's positive, it's still going to be positive, so that plus minus is going to go away. So then you have pi, the integral from minus r to r, and then this is just going to be r square minus y square dy. And then you do the integration there. Integral of r square with respect to y is going to be r square y, and the integral of negative y square with respect to y is going to be minus y cubed over 3. And then we're integrating from minus r to r. Plug in the upper boundary here, and then we get pi into r cubed minus r cubed over 3. Then we subtract the lower boundary, and then plug in minus r here, you have minus r cubed, and then plug minus r here, you get minus r cubed over 3, and the negative here is just going to turn this into a positive. Then you have r cubed over 3. So it's the upper boundary minus the lower boundary there. And then from here we get pi, and then notice that here we have r cubed minus r cubed over 3, so it's just going to be 3r cubed minus r cubed over 3 minus into minus 3r cubed plus r cubed over 3. So that's something that we're going to have. Then we have pi, and this is just going to turn into 2r cubed over 3 minus r 3r cubed plus r cubed is going to be minus 2r cubed over 3. Then negative into negative is going to be positive. Then we have 2r cubed over 3. And then simplify that, and then you get 4. 2r cubed plus 2r cubed is going to be 4r cubed over 3. Then we multiply that by pi, rearrange it, and you'll see it written by something like this: 4 over r pi r cubed. And that's a volume of a sphere. That's a volume of a sphere. So the volume of a sphere, 4/3 of pi r cubed. So you can derive any kind of geometric figure you want. You can derive a cone, whatever that you want, using the disk method. But some techniques, they don't require the disk method. The disk method will give you an incorrect answer. But cases like this, yeah, you can use the disk method. Thanks for watching. Don't forget to share and subscribe.